Hello and welcome to the Section 1 cumulative review video. I want y'all to know that I recorded a full 40-minute thing of this, before editing, and my mic wasn't working. So this is part 2 at approximately midnight, and if my brain melts, I'll try to do the math right. First, I just want to tell y'all that this test is really hard comparatively to what you've done this far. You can really imagine that this is a good benchmark for a state to national test. Some of the questions are that hard. Some of them are easier. It's a weird mix. It's not a bad thing though. But if you get a bad score comparative to whatever you normally get, don't beat yourself up too much. So long as you're ready to get skilled enough that these aren't so bad, because that's what you have to do if you want to go really far. We will review it. Either I will do a bunch of the questions and record a video, or we might do a live session. Let Mr. Lane know which one of those you prefer, or whomever, because he said he would ask. I'm willing to do either. So just if you prefer a live thing, so you can ask some questions, that's fine. If you prefer a video, I'll probably record the live thing anyways, but it's a lot more concise when I don't have to answer questions. So that's up to y'all. A big thing that you will learn with this test that you'll need to practice over time is knowing which questions to skip. If you see one and you're like, wow, I have no idea what to do on this question, normally what I'll do, and what this is a good way to do it, is circle the number of the question. And then when I'm at the end of the test, hopefully you have extra time. If you don't, I guess you got to guess. And that is something that you will have to learn to do. Same for SAT, ACT stuff. I circle it, and then at the end, if you have extra time, go back and see if you kind of something jogged your memory, especially another question. You're like, oh, I do know how to do this. Sometimes that will happen. Often that will happen. But understand that you don't just have to stare at a question and bang your head against it. That's not going to help. You just waste time. I know this page looks daunting. It's not that bad. I'm going to run through it. This is actually it. This is all just rewriting it in a couple easier ways, and this is to help explain something. So these are probabilities of two events specifically. All right. And this goes for both independent and dependent events. And I'll go over the really only difference between those. That's what this is. So the first thing to look at is this PA and PB. So that is the probability of A and probability of B. The example I'm going to use is waking up before my alarm. Waking up before A, I guess, and stubbing my toe. And then the initial explanation will be that these are completely independent. I might do these both in the same day, maybe you both eat a bagel and watch a TV show. They're not really related in any way that you can tell. Those are independent. And then dependent is when one helps to cause or stop the other. They somehow affect each other. And in that case, this does not apply. But anyways, the probability of A and B are going to be given to you, and then the probability of both happening, assuming they're independent, is the probability of one times the probability of the other. So the coin flip problems, where it's what's the probability you get two heads? The first one would be A, and the second one would be B. The probability of both happening would be 0.25. Same concept. That's A and B. It's not so simple with these types of problems. They're not 0.5. They're random decimals. So keep that in mind. This is the weird one to me. I'll explain it, and the Venn diagram really helps, I think. But this is the probability of A or B. So either A, B, or both. Just the probability that one of them happens. And that is A, probability of A, which I'll call A, plus B, minus the probability of both. Because here's what happens. If you do probability of A, that's this whole red thing, and probability of B, that's this whole blue thing. Consider those it's different sized based on this. The overlap is if they both happen. But if you just add A plus B, you count this area twice. And then you're overestimating what the probability of that is. So you have to subtract it once, so that you're essentially getting the net area of this weird oblong, infinity-ish shape. And that's why you have to subtract it. Don't forget that. The probability of neither happening is 1, because 1 always represents like the cumulative, every single possibility as far as you're concerned for certain problem, or like every possible set of coin flips would add up to 1, all the probabilities. And this is the same thing. So if you 1 minus P of A or B, there's a possibility, and let's say it's like a box around here. You can think of it all, wow, that's a box. You can think of it all as like this box is 1. And the area of these two things is the probability of these things happening. And then all of that blank area is the remainder. And that's where neither of these things happen. Cool. This is just, I think it's a lot easier to look at than this. It's the same thing, but instead of the P's, which is the proper way to do it, it's this. And here's another thing. This is, I guess, relevant if you are in actual statistics. The correct way to write A and B is P, probability of the union of A and B. And it kind of looks like an N anyway, so I just write this because it's easier, like D and D. And then the A or B instead of AOB, which just makes more sense to me, is this weird, like, honestly, it could be the flip side. I don't know. I don't like these. You'll have to do them in math at some point, and then remember them then, and then, depending on what you do later, just, I guess. For dependent events, so like if, and this one kind of makes sense, if waking up before my alarm, say, made me more tired, and thus I was more likely to stub my toe, the probability of both would be something different, probably higher than it would be if I just multiplied the probability of each individually together. So certain problems will give you the A and B, and in that case, do not calculate it or you'll get the wrong answer. Use the one they give you, and that's it. So, problem number 1 regarding this. Real quick, I'm going to make sure my mic's working, because this happened. This is why I had to redo it. Cool. Mic's working. What else do I have open? Oh my. I have like Discord open for part of that, so they're going to see that I'm using Discord. That's fine. I can't edit that part out. I could. I don't care to. So this is practice problem number 1 with these equations. L and M, whatever they may be, are independent events. Probability of L is 0.55, and probability of L and M is 0.26. What is the probability of M? So this is involving that first equation up there. We have A and B, and we have A, or, L, and M. So 0.55 times M, or probability of M, that I don't feel like writing, equals 0.26, right? So we go into our calculator, ignore all this, it's doing physics. We go into the calculator, we solve this, we divide both sides by 0.55. I swear I can write straight lines sometimes. It's late, y'all. I was almost done. 0.26 divided by 0.55. That's the probability of M. 47. 47% of the time, M happens. So that's how this goes. This is the simplest type of problem you can get with this, where they just tell you flat out like it's just the formula. This next one this is a multi-part one because it kind of covers most of the basic bases of what they can do. They can throw more stuff into it, and there are a couple problems on here that just, and unless you are really well versed in math, you'll not have seen before, and we'll go over them later. Try to do them on the test itself, but like, don't beat yourself up if you can't. Try your best. You want to get the highest score you can, but like, it's gonna be rough. Good luck. The probability that Johnny is late to work is 0.15. The probability that Johnny does not eat lunch is 0.3. The probability that Johnny does not eat lunch and that he is late to work is 0.2. So somehow those two interact, and the probability of both happening is way higher than it would be if we multiplied them together. And now we'll see what is the probability that Johnny is late to work or does not eat lunch. So that's this middle equation. We already have A and B, so it's not that hard. A is 0.15 plus that 0.3 for B minus are both 0.2 because we got to subtract that extra count. And this is 0.25. Quarter chance he does at least one of those things. What is the probability that Johnny is neither late nor misses lunch? And that is just this n equals 1 minus AOB. And that's what we just calculated. So 75% of his days does Johnny get to work on time and eat lunch. Good for him. I don't know if that's a good success rate or not, but I should probably eat lunch every day. These are the most basic ways that these will come into play. And the best way to remember these, I find, is to actually just kind of say them in English. That's again, just for me. Maybe you need to memorize. I tried to color code them for you so you can kind of see. This is one of the ones that might be beneficial to write down at the beginning of the test, just like the financial formulas. This is a separate thing. This is kind of like the counting problems, but not quite. I'll show you why. 33% of Braggists are brown. It's an animal I made up. Of those, 12 have blue scales. 12% have blue scales. What is the probability of some random Braggist, of all of them on this alien planet, being brown with blue scales? So if you go pick one animal, what's the probability it has both of these things? You'd also think of this as what's the probability that someone is a redhead and has blue eyes? Something like that. That would be a bigger percentage, but you get what I'm saying. So first, if we're picking a random one, there's only a 33% chance that it's brown at all. And then of those, there's a 12% chance, so we're going to multiply inside of that, essentially. There's a 12% chance that they will have blue scales. Sorry, I'm grabbing my reference sheets. And this comes out to 0.0396. It's a very unique thing. And again, you can think of this kind of like that other one. This is all of the Braggists, and then a third of them are brown. And then inside of that, 12% are blue scaled. That's more than 12%, but you get what I'm saying. So out of all of them, this is the amount. And this is 3.96%. This is the amount that have both. On any given day, there's a 20% chance of fog. Johnny, different Johnny, is always on time to work when it is not foggy, but when it is, he is late 60% of the time. So the fog makes him late often. What is the probability that Johnny is late exactly 2 out of 7 days? So this is a binomial distribution problem, if you remember those, like the binom. This is a PDF. The PDF is for exactly 2 out of something, or exactly X out of Y, whatever. Binom CDF is for between 2 and 3 days, or some range. So in this case, we need 1%, because if you remember, this takes N, which is number of trials, the percentage success rate, and the number of successes you're looking for in some order. I don't remember which one's which, but we need 1%. So on every day, there's a 20% chance of fog. So again, we can think of the box, 20% chance of fog. And on those days, Johnny is late 60% of the time. So we're trying to find this area. And that is 0.2 to the 20% times 0.6, which is 0.12. So that's going to be our percent success rate, right? And then we want to know 2 out of 7 days, what's the probability that that happens? So we're going to go to our calculator, menu, distributions, binomial PDF, and we have 7 days we're looking at. The probability of success is at 0.12, and the X value, how many we want to get, is 2 days out of the 7. So there is approximately a 16% chance, 0.16, that he misses exactly 2 out of 7 days of work, which is more than you think, right? It's probably about 2 is the most normal amount, like 1 or 2. So that's a binomial distribution problem that has a built-in component of like that box in a box thing, the percentage of a percentage. This isn't that complicated of a problem. I wanted to, sometimes this wording is a little trippy, and I'll show you why. How many unique 3-digit numbers can be formed with 0 to 7 and no reused digits? So if you think of like a passcode that has 3 digits, there are 10 digits, 0 to 9. And that's important to note. There's not 9 digits in 0 to 9, it's 10, because 0 is included. 10, 10, 10. You have a total possibility of 1,000 different unique passcodes that you could make. But this has a stipulation. That is, you only have 0 to 7 and no reused digits. And this, because it doesn't say like a passcode or something like that, it's implied that you can't put 0 in front, because 037 is not a unique, it's not a 3-digit number, it's 37. So for the first one, technically we have 8 digits we can choose from, but we can't reuse them, and the first one we can't use 0, so we have 7 for the first option. For the second one, we have that pool of 8 normally, but we've used 1, so it's actually 7 again. And then for the last one, same thing, we have a pool of 8, but we've used 2, so it's 6. So there are 294 unique numbers you can make with these stipulations. And again, you just got to really think about, like, what does that mean? It means you have 8 options and no reused digits. That means we subtract 1 each time, which you've done before. And then the weird thing to keep in mind is that this has 1 less option because you can't use 0 in the first one. Sometimes you can, in this like very limited wording, you cannot. This one's kind of weird. This is very similar, and this is why I wanted to show it, to just how many ways can 10 people stand in a line. And it's just 10 factorial, right? Because we got 10, 9, 8, 7, yada, yada, yada. This is similar, but it's different. This is the equation for this, and I'll show you why. One, we're just going to pretend that like each person is numbered. 6, 7, 8, 9, 10. This is the same as if we shifted them all over 1. So, like the line, if we shifted the last person to the front, that's different. But in this case, we shift the last person to the front, but keep the order the same. It's actually the same. And that's why instead of 10 factorial, it's 9 factorial ways. You can shift this rug around or spin how you're looking at it, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the same as 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. And I can't really explain why better than that. It took me forever to even understand it to that degree. Good luck. There is a variation of this that you don't have to deal with on this test, but that might come up at some point, of if it's like a key ring or say a bracelet with charms on it. In that case, sometimes they'll specify that you can, the clockwise and counterclockwise arrangements are not unique because they're just 180-degree spins and or rotational flips. So if you had a bracelet and you flipped it over, you didn't change anything about the order, but it did. In this case, we are counting that, the 9 factorial. So we're saying that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is different than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the other direction. That's what the 9 factorial is. If the flipping is a stipulation, and they might say that clockwise and counterclockwise do not count towards uniqueness, you just divide this by 2 for the flip. Why is it 2? It is. It's technically 2 factorial for math reasons, but that's just 2 times 1, it's 2. So you divide it by 2 if they say something about flipping doesn't count. If they say flipping does count, it's just n minus 1 factorial. If a coin is flipped 7 times in a row, what is the probability of obtaining at least 1 head and 1 tail? These are interesting problems if you're in statistics, or you will be, or you probably have to do it in college. this is the same as saying, what's the chance that you don't get only heads or only tails for 7 flips? And this goes for any number of flips, but we're going to do 7. This also goes for dice. So if they say, the same way you use coin flips a lot, you can use them for binomial distributions as well. Sometimes they'll say, if you roll a bunch of dice, what's the probability of odds and evens in some sort of way? You treat those the exact same as coin flips, because there's a 0.5 chance of even, 0.5 chance of odds. So it's the same kind of problem set up. Don't get freaked out because it's die instead of the other thing. So here, we're looking for literally every single possibility except these two. Because for every other possibility, you have at least one head and a tail. You know what I'm saying? So that is 1. That's all the possibilities. Minus the possibility of this. And that's one thing we're going to add. Minus the possibility of this. So we're taking out these 2 options from the whole pool. And each of these has a 0.5 to the 7th, because there's 7 slots, 0.5 in each of them, chance of happening. So if we go into the calculator, we do 1 minus 2 times 0.5 to the 7th. That's the chance you get at least 1 heads and tails. Or rather, the chance you don't get all heads or all tails. I'll say 0.984. And this is the type of problem that will come up. And usually, actually, it's only one thing. But what's the probability of something, and there's one thing you subtract. But if there's multiple options like this, then you have to subtract each of them individually. I believe this is second to last question. This is a binomial distribution problem. I included it because I think the wording is really weird. It kind of confused me, so I assumed it could confuse some other people. A class has a historic passing rate of 95%, which means normally every year 95% of the students pass. What is the probability that this year's cohort of 100 students, so this year's class of all seniors or whatever, taking physics, underperforms the average? So this is asking, what's the chance that only 94% or less, so less than 95% rather, or less 94, pass. So it's anywhere from 0, everyone fails, to 94%. So that's why it's binomial distribution. And the chance that each individual student passes is 95% per historical statistics. So this is a binomial CDF problem, because there's a range of things we're looking for. And our number is 100. Well, I'll just go do the thing. So menu 5, 5B, I think is the CDF, if you prefer to go real quick through it. Number of trials 100. Probability of success. You could do one or the other ways. I'm going to say there's a 0.95% chance each of them passes. And the lower bound is 0, which would be no one passes. And the upper bound is 94 of them pass. We want to know what's the probability that between 0 and 94 of them pass. That would be less than average. And, okay. Well, you saw that. I guess I'll show you the inverse so you can kind of understand what I'm talking about. I don't know why it didn't. I hit cancel? I don't know. We'll say 100 students. There's a 5% chance any of them fail. And we want to know what's the probability that between between 6 and 100 of them fail. So this is like the other way of looking at it, is a good way to think about it. And this will give us 0.384. And if we do it the other way, which I can quickly do just by switching around some stuff here. This is, you can technically type it all out like this. Exact same. So you can do either way. You can think about it either way. Whichever one comes more naturally. That's why it was so weird to me, is it's I wasn't sure what to do. So 0.384, so 38.4% chance that they go under by a little bit or a lot. They underperform. This is the last one. There are a lot of financial problems. I can't really show you every single possible arrangement because it's too much, and like that's not going to help you in the long run. You can't memorize every way they'll do it. What you need to know is the simple interest formula, which is final value equals P times 1 plus rate times time, and the compound formula, which is similar. P times principal, how much you put initially, 1 plus R, which is the percent rate, over N, which is the number of times per T that you compound. So if they say like 5% annual, but compounded monthly, then this would be 12. And you'd also put 12 and the number of years up here. So in this case, this gives us a bunch of these except for one. Sometimes you have to solve around. What you have to get to is that there's only one thing you don't know, and then you can solve for it. In this case, it gives us, it says, at what initial deposit, so that's asking for the principal, would an account with 5% annual interest compounded monthly be worth $7,889.95 after 7 years? Dollars. Who cares? So we have everything except for one of the things. We don't have the principal. So we're going to arrange our stuff. The final value is 7889.95 equals principal, which we don't know, times 1 plus 0.05 over 12, because it's compounded monthly, raised to the 12 times t, which is 7 years. And you could solve this by dividing out the p, doing all sorts of stuff. I'm going to show you NSolve. I'm sure a lot of you know it. I probably mentioned it before. The thing I'll mention about NSolve is, for one, you can only use it with linear equations. If you use it for anything else, you'll only get the first answer the computer finds. So if something like a quadratic has multiple answers, systems of equations, it will not work for this until you already do most of the work. It's only for linear equations, which this technically will be. There's only one value we care about that will come out of this. It would turn linear eventually, because this is technically one huge constant once we parse it all out. So 7889.95 equals x, and the thing I'll say about numsolve is that you really can't, so normally you could just put like parentheses here. Don't do that. Put the multiply sign. If you don't, sometimes it messes up the syntax, and like it puts parentheses all over the place, and then you lose. You have to start all over on the typing it all out, which is a waste of time. 1 plus, and again, try to do as much syntax as you can, as succinctly as you can, because you mess up one parentheses, it's impossible to find where it is sometimes. And then this doesn't work at all. Over 12 raised to 12 times 7. And then at the end of NSolve, which if you don't type it out is menu algebra 1 numerical solve. I don't want to do it though. I already have it. At the very end, you need to go to the very end inside that last parenthesis and do comma, whatever variable you used in here. I could have put p. X is just like easily found on your calculator. It's at the very bottom. So that's why I just use X if it's only one variable, because you always know where it is. And that is the initial dollar value that, fitting those criteria of this, would end up at this value. Again, you can see how you could do the algebra, but it's easier to just type it out most of the time. So what is it, $5,564? That's our principal. That's the last problem I have. I will say again, good luck. Try your absolute best. If this test kicks you in the butt, it's fine. Make it kick your butt as little as you can. Really push yourself. But we will go over it in one way or another because it needs to be done. Consider this like a reality check. This is what the test will be like, assuming you make the team, which should be your goal, and take the state test at least, and ideally take the national test, because going as a team or as an individual is a really fun experience. I really suggest you strive for it. I loved when I did it. But you got to get good at math or they're not going to let you in. So practice hard. And that's all I got to say.